This is number 17 on your logarithms review, and we're dealing with an exponential equation. So anytime we're dealing with an exponential equation, we want to try to just get the e's by themselves. So the first thing we would have to do is get rid of this dividing by 2. So we would just multiply both sides by 2. So we'd get e to the x minus e to the negative x equals negative 4. Now, we still want to be able to get the e's by themselves, but in order to do this, the reason we want to do that is so we could take the natural log of both sides. But with this subtraction in here, and then there'd be an addition over here if we moved it, that won't work. So when that doesn't work, we go about trying to factor. So again, we have to figure out a way to make this factorable. Well, the easiest thing for us to factor is quadratic, so I'm going to try to figure out a way to make this a quadratic. In order to do this, I'm going to need an e to the x squared. So I'm going to times everything by e to the x. Because then that would give me e to the x squared times, well, negative e to the negative x times e to the x is equal to negative e to the 0. Because remember, when you're multiplying, you add the exponents. And it equals negative 4e to the x. Then I'm going to move everything over and simplify. So then I'd get e to the x squared. I'm going to add this 4ex over. And then subtract, well, e to the 0 is just 1. And all that's equal to 0. So then it's like we have a quadratic where our variable is e to the x. So I'd have to first see if this factors. I have to think, okay, what multiplies up to negative 1 but adds it to 4? Well, nothing exists. So since that doesn't exist, we have to use the quadratic formula. So we get e to the x is equal to negative b, so negative 4, plus or minus the square root of b squared, which is 4, so 4 squared is 16, plus 4 times a, which is 1, times c, which is negative 1, all over 2a. And a is 1, so it's just all over 2. Oh, and this should have been minus. Sorry about that. So when you go ahead and do this and simplify it, you get e to the x is equal to negative 4 plus or minus the square root of 20 all over 2. And we know the square root of 20 simplifies yet. The square root of 20 is equal to negative 4 plus or minus the square root of 4 times 5. Which then we have negative 4 plus or minus 2 square root of 5 divided by 2, and we can still keep simplifying. So then we get e to the x equals negative 2 plus or minus the square root of 5. Now, when you get to here, we know that exponential functions, our domain is all real numbers, but our range is y has to be greater than 0. So, in other words, e to the x will never give us something that's a negative number. So I have to look. Since e to the x is never going to be negative, I know it can't be negative 2 minus the square root of 5 because that would be negative. But I know the square root of 5 is slightly bigger than 2, so negative 2 plus the square root of 5 will work. So I have e to the x equals negative 2 plus the square root of 5. Now I'm dealing with an exponential function again. My variable is my exponent, so to get rid of that I can use logs or natural logs. Well here, since I'm dealing with e, I'm going to use the natural log because that undoes everything. So I get the natural log of e to the x equals the natural log of negative 2 plus the square root of 5. Well, I know the natural log and e, these are inverses of each other, and by the power product, I can bring that x out front to get this. Then, since these are inverses of each other, they just cancel each other out. And I'm left with x is equal to the natural log of negative 2 plus the square root of 5. Since you aren't using a calculator, that would be your final answer. If you wanted to use a calculator, though, you could type this in and get an approximate. But this is your exact answer.